Yeah, good evening, guys. Welcome to another Dancers Online lectures. Just a short one today. We're going to look at we're going to continue from our last lecture. Yesterday we discussed some few issues about Hardy Weinberg, the principles underlying Hardy Weinberg's principle, and then I gave a question to the students to answer. I hope most of you will get that answer right. So once again, welcome to the platform where we make biology as simple as we can. Now today we're going to look at interesting things, and I would advise us to look at the matters on the table and forget about every other thing. Now we're going to look at some of the possible causes of evolution. If you recall what we've discussed yesterday, we looked at a situation where in a population there is no possibility for evolution to take place. And this is in connection with what we say it is the Hardy-Weinberg's principle, where he made mention, or they made mention of certain principles and conditions that must be present in a population to make sure that evolution do not occur in that particular population. So we have to reflect our mind back to those principles that Hardy and Weinberg mentioned in a non-evolving population, or otherwise in an equilibrium population. So those factors that we mentioned, any deviation from those principles would definitely be a potential factor to instigate evolution to take place. So one of those factors is the mutation. Mutation, if you know what mutation is, that is the changes in the gene sequence or the DNA sequence. That is what mutation is all about. The second factor is the gene flow. That is the exchange of genetic material among individual populations. Natural selection, non-random mating, and small population size. So when you look at these five principles, in Hardy-Weinberg, it says there should not be any mutation. So therefore, if there is mutation, we expect evolution. If there is a gene flow, we expect evolution to occur. If there is a natural selection, we expect that evolution will occur. If there is a non-random mating, we expect that evolution should happen. If there is a small population size, we definitely expect that evolution will occur. Now, I want to reflect your mind back to this imaginative road to the Homo sapiens. When you studied evolution or biology, you get to be familiar with this roadmap to the Homo sapien, or the modern Homo sapien, that is ourselves. Now, if you look at the roadmap, think of these bipedal organisms here. They were not that much erected, like to stand straight, but they were also using their other pair of a limb to be able to walk properly. So you can see that evolution from this Philopidens to the modern Homo sapiens. And that reminds me to the Homo erectus here. You can see that transition from the Philopidens to the Homo erectus here. You can see the transition from using the second limbs as an organ of movement to slightly be able to walk up using less of the other limbs. So from the Homo erectus, you can see that we're well erected, and even though facially and hair body-wise, there is a gradual decrease up to the point that Homo sapien, the modern version of Homo sapien that represent us, comes into place. So there are so many physical appearances differences from the first phase of this evolution in many millions and billions of years ago to this modern Homo sapien. An expectation that even this modern Homo sapien, and many millions of years later, there's going to be a gradual differences. The face bones, the body posture, the intelligence level, and so many factors might happen in the near future. So that is what evolution is all about. Evolution has to do with a population, and this do not just happen instantly. It happens after so many millions and billions of years of accumulated factors, and the effect of it can be seen in a population. Now, one of the factors that can cause evolution, now we know that there should be mutation. But what is mutation itself? Mutations will be the original source of genetic variability. If you look at the population, you see individual members are different in so many different regards. Some will have black hair, some will have gray hair, some will have brown hair and curly hair. All these things are a result of mutation. It causes genetic and phenotypic variability among individual members in a population. So it is the change in the DNA sequence. If you look at the DNA sequence, normally DNA sequence will be a very perfect shape and in a perfect arrangement of the nucleotides. But due to mutation, that is during the cell division, either mitosis or meiosis, you see that in every cell, the machine or the mechanism of the cell division involves so many different enzymes and so many complex processes. During these complex processes, the cell is not perfect either. They make some kind of replicating errors or mistakes in the replication. And even though the cell itself has so many proofreading enzymes, we call them proofreading enzymes or the DNA repairing enzymes. These DNA repairing enzymes are those enzymes that make sure that during the cell division or during the copying of the DNA or the replication of the DNA, they make sure that they correct some of those errors that the DNA replication is given. For example, if one nucleotide is wrongly placed as a substitute to the other nucleotides, these DNA repairing enzymes will come and make sure that they place the new nucleotides, the correct nucleotides, to make sure that the sequences matches. But of course, no mechanism is perfect either, and so do the DNA repairing enzymes are not. They also sometimes forget, and then they cannot fix some of these replication errors, and these replication errors will be passed on and then will be in our genetic material. So all the unpaired mutations, so they will enter into our gametes, and then they will pass to the offsprings and finally enter the gene pool of the population. And this will cause a genetic variability. That's why when you look at the individual population, you can see some members will be having a very dark hair, some will have the curly hair, and all those things. These are caused as a result of accumulation of mutation, and it will cause a genetic variability within the organisms. So now let's look at the inherited mutations. They are very rare, but they are very important. Mutation can be passed from one generation to the next, but this is very rare because according to research, in every 50,000 newly born babies, only one single baby will pass those accumulated mutations from one generation to the other. But these inherited mutations could be very important as well. Of course, sometimes they can be later, but they are so important. And what makes them very important is that, let's say the mutation becomes a beneficiary one. Probably in a population where a cow population are living in an area where they have very high competition with the other predators like lion. So there comes to the mutation came where a particular gene has been modified in a way that it gives this cow an extra speed and extra weight and extra fighting skills to make sure that they are able to adapt and live within those predators perfectly. So if this phenotype and genotype could be passed from one generation to the next, this we consider it as a very beneficiary mutation, a very beneficiary mutation, because it allows them to live comfortably and successfully in their environment. So that will come as a result of natural selection. Mutation cannot be said it's supposed to be happen like this or the outcome should be like this. Mutation is something which is spontaneous. It happens when it is supposed to be happen, and its accumulation is not just 1 day or 2 days. It takes billions and billions of years. Now on this picture, this funny picture of myself, the question now is, what then makes it seen in individuals? Accumulations over time will be the answer because it takes billions of years. Now I want you students to look at these two pictures of mine. The first picture, you see the phenotypic differences on the colors. I want the students to think and say if you can say that I have gone through mutation or not. Considering the fact that mutation occur in a population and not in the individuals. So the answer to this, I am an individual. You cannot use an individual as a mutation. Individuals do not mutate, or they do not evolve, rather. It is the population that evolves, and individuals do not evolve. So you cannot say, I went through evolution from this picture to this other picture. It is the population that evolves, and individuals do not evolve. So I want the students to understand this part perfectly. Individuals are not evolving, but rather the population that evolves. So thank you all for watching this video, and I hope this is really going to help. As usual, click and subscribe to the channel. If you have any doubt or question regarding today's lecture, you feel free to send a comment under the video, and I will respond as soon as I can, as usual. So thank you all, and enjoy today's lecture. See you all tomorrow, and we will get to another topic, interestingly,